Okay, so we left last issue with started with MarkovTextGenerator struct. I think now is the time to sort of write some more tests to just verify it, because obviously this is producing our data for our game, so we need to be a bit more careful with it, and also we need to generate some data, save it off so that we can load it into the game. So testing is actually going to help us with that too. So today is about testing. We've already got a test case where we created the code initially, but we need to add some more, and I need to remember to start the timer. So here we go, 25 minutes on the clock. Let's see what we can do. So we need to just verify a couple of things on the test. First of all, we need to make sure it's generating lowercase and things like that. Oops. Text, not test. It's important. So I'm gonna this is going to be an array of keys, I think. So it's an array. And then we're going to take some we're going to right, so that would generate the key ABC. So .dictionary .keys .map. Where's my map? So let's try that test. We don't need the playground generation. That's going to run long, so disable that. Below. Okay, we've got nil. So, because we're using force unwrap, and we have nothing in the dictionary. So, if we've got nothing in the dictionary, we need to, well, we've got to have a precondition of the length of the text because it's no. I've just given it we need to have at least 5 because we're dropping 4, and that would be ridiculous. So it's got to be, unless since this is really a constant. So what are we going to say? N-gram length. That's actually, we're actually equal to 3. So this it's got to be bigger than or equal to plus 2. And this is going to be plus 1. Same here. So I've got a bit of repetition there, but we'll leave that. So this says not enough text. I'm going to run my tests again. Okay, not enough text to make the generator, and that's because we called it with the text ABC, which is not enough. Wow, okay. It's actually, we need that condition later on, because what we need to do is futz the text first. So we've got this, but really we want to change what the text is. So if we filter it here, no, if we map it, and we say we're going to split it on white space, and I was thinking that I also need to think about, I want things that are commas separated or full stops or say semicolons, colons to be treated as spaces. So if that's true, then we're going to return a space, otherwise we're going to return the character. And we're going to lowercase it here, since we're mapping over it already, might as well. Then we need to replace all the then we're going to split it on white space. not some actual precondition. Actually, I think we need to precondition. Right. The precondition is so how's that work? Yeah, it still does that because we've still, even though we've now got that, we actually have one value. Still breaking here because we don't have any starts. The reason we don't have any starts is because the dictionary is empty. Oh God, wrong button. Pressing the wrong button. So it should break at that precondition. So that's the 5 we think we needed. There you go. Do we not think that, and should really have to be the space because that does lead to D. This failed, so I think that's easy to fix because we just need to append a space to the end of the string so that it catches the last letter if there's no new line or anything like that. And of course, just sort it. Okay, so let's do one test if it ignores punctuation. Okay, so that's pretty good. Now we have to, I mean obviously this isn't a comprehensive set of tests, but because we're going to generate a large large output, the dictionary from this is pretty big, and we need to save it off anyway because we don't want to generate it every time because it's going to be the same each time. So we want to save it off to disk. And now the best way to do that, or not the best, nothing's ever the best way, a way to do that is to make this codable so we can save it to disk, and then use this really cool framework called snapshot testing by 0.3 to actually save it and do some tests. So let's make this codable first. If we want it to be codable, we need to give it some coding keys. Now to make this codable, the only thing I need to save is the dictionary, but also you might as well save starts, or we're going to recalculate starts. I think we will save the starts. And then to make something codable, we have to give it a init from a decoder, and we need to give it a func encode. So let's encode it first. No, let's decode it first. So make a container. Keyed by our coding keys. Then we can just do self.dictionary can be equal to our container dot decode. We want this type, so let's make a type alias. What is it? It's that is decoded like that. Try, and then self.starts equal to container. It's just an array of strings. I need to try these as well. Then I can create my iterator index the same way I did before. And create my buffer. a bit of repeated code here, which I'm not really happy with. So I might give it another constructor. Take that out. In fact, just copy this here. You know what? I think I might just keep the dictionary. No. Right. Now we do this. And quickly encode it. Container. Okay. Oh, need to try these. Right, so that's a Codable interface added to the generator. So let's just quickly test it with. I need to get the snapshot testing. Oh God! Added to. Here we go. So let's just finish this little piece off. Snapshot testing. Takes a while. So got that added. Now I'm going to try to use it. So I should be able to import it, hopefully. And then let's make a quick codable test, and then we'll generate some code. So test codable. What we're going to do is assert a snapshot. Let's make of a and this is the cool bit. You can just ask for it to be as JSON, and then we can just run these tests. Oh, no, we can't. We need to include a couple of things. I think we need to link it here. I think we need to do this. And also, because we're on a Mac, we need to disable the sandbox for this. Right, what that says is it's failed. So it should have created an artifact which we can add. Yeah, so we've got this snapshots folder now. If we look in that, we've got the snapshot for brown cat, how brown cat. So this has created a JSON for this with the dictionary here. So these are the trigrams, and these are the letters that follow. So BR, brown, obviously there's not a lot of choice. OW space can be followed by N or a B. And now now it's generated that. If we execute this test again, it should succeed. Oh, it says it does not match reference. It's because it's not sorted by the look of it. That's weird. The how now is being moved. Oh, it's in the starts. So why don't we I know I've gone over time, but why don't we order the starts, because that will just make things nicer anyway. So when we create the starts, now try it. Oh, we need to record a new snapshot. Now, hopefully, we'll get success. Wee! Yes, right. So that's how you use these snapshot tests. When it first runs, it creates like it's sort of what it's trying to match if it doesn't exist. But if it exists, you need to kind of do that kind of hack where you set record to true. And now when we run this, it should always succeed, because it was failing because I wasn't sorting the array, and unsorted arrays don't equate. So we could have fixed that in a different way, but sorting it means that we've got a nice artifact when we look at the JSON. This is now sorted, so we can start words like this. Sequences, that's a bit weird. Obviously it's not entirely brilliant, but it's not actually English we're generating, so it's alien English, so that will do. Okay, that's it. Thank you.